Alright, our third derivative video is going to be to take a look at the chain rule, which is a really useful kind of little shortcut here that you actually have probably kind of seen before, or at least intuitively have used before when you looked at the product rule and some other things, or the power rule. But the chain rule is basically used most times when you have a function that looks like this. And it's like a polynomial here, in this case a binomial, raised to a power, right? If the whole thing is raised to a power, we're going to use the chain rule. And the chain rule basically says, without getting too bogged down here in detail and kind of theory here, we're not going to generalize, we're just going to show by example. The chain rule looks a lot like the power rule. When you take the power and you multiply it by the thing in front, in this case there's nothing out there, and then we're going to rewrite whatever's in the parentheses. We're going to reduce that exponent by 1. And then here's the different part. So far it's exactly like the power rule, but here we want to multiply it by the derivative of what's inside, which is going to be 12x to the first plus 8. Alright, in the power rule we actually did that, right? If we had something like 7x squared, the derivative of that, f prime, is 14x to the first power times, believe it or not, the derivative of this thing right here is just 1, which doesn't really change. That's why the power rule doesn't really, you don't really think of it as a chain rule, but it actually is. In any event, it might be a good idea then to, a lot of times you'll have to take the first term and multiply it by this term out here. This term is a linear term, so we can multiply those two together. So what I'm going to do is take 3 times the quantity 12x plus 8, and then keep that just like that. This is a binomial raised to a power of 2, so we can't really combine them quite as well here. So we're going to just simply distribute here 36, 24. So in parentheses I'll have 36x plus 24, close parentheses, times this quantity. And that's your derivative. Let's try another one. Chain rule here. Let's call this example 2 g of x. Let's say we have a number out in front, so -7, and then inside we have -2x to the -5th plus 10x squared minus 6x plus, let's call it 8, raised to the -5th power. Alright, a little bit more complicated here. So we're going to go g of x. G of x is equal to, alright, we're going to take the power rule again. We're going to take -5 times the thing in front. -5 times -7 is positive 35. So positive 35. And then we're going to rewrite the entire polynomial without changing it one bit. We're going to reduce that power by 1. Remember, when you have a negative and you take -5 minus 1, it's actually -6. And then we're going to multiply it by the derivative of what's inside. So it's going to be, let's see, power rule 10x to the -6th plus 20x minus 6 plus 0, which we don't need to write that plus 0, so I'll just kind of bring this parenthesis in here. And again, it's probably a good idea to get into a habit of taking your lead term out here and multiplying it by this last term right here. So I'll do that now. We have 35 times the quantity 10x to the -6 plus 20x minus 6. And then this big 4-term polynomial doesn't change. So we're gonna distribute this in. So we get 350. Let's see, g prime is 350 x to the -6th plus, let's see, that's got to be 700, right? 700 x minus, let's see, 180 and 3210. and then this remains unchanged. Alright, again, we have some negative exponents to deal with here, so it's probably a good idea. And at this point, you know, depending on what your teacher is looking for, you can probably stop here. You know, your teacher might not require you to get rid of all the negative exponents, but, you know, in my class, I'm certainly probably going to. The first thing I'm going to take a look at is the fact that this whole first trinomial is raised to the first power, and this whole second trinomial is raised to a negative power. So I'm going to sort of take care of that right now. I'm going to keep this whole first trinomial in the top. You can put it in parentheses if you want. And then this entire 4-term polynomial, since it's raised to a negative power, I'm going to move the entire thing to the bottom of our fraction here. Remember, the negative exponent rule tells us that anything raised to a negative power moves to the bottom, and that power becomes a positive. All right, again, you know, depending on what your teacher's looking for, he or she might want you to take that and put it as 350 over x to the 6th, negative 2 over x to the 5th. But for this video, we're going to stop right there and leave this as our answer. That is our derivative using the chain rule.